Hi, my name is John Chen. I am presenting our group project, sleep stage classification and sleep quality study based on EEG data. And this presentation comes with three parts. First part is introduction, second one is approach, and then lastly, I'm going to talk about the result and conclusion. The introduction and sleep quality is very important part of our health, and data that shows how well people sleep have a significant implication on their health status. And therefore, if we can extract practical information from sleep data, doctors and other experts can provide more precise estimations on patients' health conditions, and especially for our neurosystems. And there's many useful for EEG data, which probably and the result of our classification, which can determine if a patient sleep well, or have the like sleep apnea, and other disorders as well. So approach. We implement both CNN and bidirectional LSTM approach for our project. The CNN is very useful too to train and learn filters from EEG data, as well as to extract time invariance features. And the bidirectional LST is a good way to carry out the time series prediction because it can use both prior and post informations, and it can prevent the model from being imbalanced. The data we are using is a SLEEP EDF, which means European Data Format Database. This database comes from the research of sleep neural feedbacks, and the database contains the 61 polysonogram and accompanying hypnograms, and were from 76 healthy Caucasians. And we define the standard 5 sleeping stage, which is W, N1, N2, N3, and REM. Our target for to come out this from studying this data is to have the to clearly classify the 5 stage from a certain EEG input. The process and training the data. There are two main stages within our algorithms, and the algorithm first training first part of a model, which called the representation learning part. The two CNN are stacked on a softmax function layer whose parameters are later discovered after pre-training. The pre-model is training with the class balance training set using Allen. We use oversampling strategies here to enroll all sleep stages to have the same numbers of samples. The second stage of the training algorithm is to supervise fine-tuning. We replace the pre-model with parameters of two CNNs, and then the model is trained with the sequence training set with the LMs using two different learning rate. Here we use a smaller training rate for CNN and the large one for the second part, which is bidirectional. I'm sorry, which we call residual learning part in the softmax layer. The reason for such setting is described in our papers. In order to prevent exploding gradients, we also use a widely used heuristic gradient clipping technique when dealing with such troubles. And each data was split into 30-second approach. And so we get an approach training using CNN, and then after first part, we use bidirectional as LSTM as in summary. So in our results, we get overall accuracy of 82%, and if you can see, mostly was between most testing result was between 86 and the 88% for accuracy. The only setback we have was the N1, which is not very accurate compared to other 4 stages. But we still was able to achieve over 82% of accuracy, even with the N1. So potential implementation, we can of course use multiple channels instead of the way we are using now, and train perhaps with a fewer approach, and implement more folds for cross validations. Our currently only use one fold for cross validation, but we use 24 for the training. And of course, we can always optimize our MATLAB functions. And currently, with the MATLAB function, I don't think there's much optimization being done to that. So it still has many room to improve the performance. That's all. Thank you.